So, last week was kind of strange for all of us probably. Sorry for my spontaneous absence. How are you guys feeling about the material that well, last week was already going to be kind of basically like halfway almost. So we're losing a day of assessments, which is fine. So, how did you guys feel about the homework so far, the quiz if you've looked at it yet, based on just using the information that we've gone over so far and that was made available towards the end of last week for you guys? How comfortable are you guys feeling?
It was pretty good. I did.
Okay. And I do want to spend just a little bit of time for the class. If anyone has any questions about the homework, ideally I'd like it to be due tonight. And so far, all of my estimations seem to say that we'll be okay if it is due tonight, but I want to check in with you guys, see if you have any pressing questions, and we can go over specific cases absolutely together to make sure that you guys are as possible for it. Now, I think everyone's in a good spot for it because whatever I did not say to you in this room, I pretty much said to you in lab. So that might not have been part of the official lecture, but it was in lab, so you've seen all the material. But there's certainly been, and there's been enough time to go through it. So, sorry, I'm rambling. It's been a very strange. Last week was strange, the weekend was strange, so I'm still kind of getting back to a normal place in my brain. And I'm thirsty.
Were you sick?
No. So my fiance had something. Whatever it was definitely bacterial. She's had strep problems her whole life. It just flares up arbitrarily once every 6 months or
Does
so.
she have her tonsils?
She does have her tonsils.
She can take it out.
I have heard, that's a separate story. Point is, something was happening. We were 98% certain it was either strep or something else bacterial. When the doctor's office got strep test, it wasn't strep. But the doctor said, take the antibacterial anyway, and until you get a test confirming it's not COVID, you still need to treat it like it is, even though it's very clearly bacterial, it's still unknown disease. And since I've been spending the prior days with her, I also went into isolation until we got that official declaration. And then tornado happened, but didn't. So that's just kind of what the tail end of last week for me was a flurry of storms and not storms and sick but not sick. So she's fine, I'm fine. No one's sick. Did I answer the question?
The tonsils?
Oh, she has her tonsils. She is currently in nursing school. She's told me, like, I feel as though having your tonsils out has other long-term side effects.
I got mine taken out when I was like 8.
Okay.
No, I was like 7.
Like, the
And
longer you wait, the more damage you get. So, like, if you're older, it's like, is it worth it? Because I mean, there's more problems. And they can grow back, technically. It's rare, but it can happen.
mine did not grow back. I've never heard of that. But it is a lot. I was her. I mean strep probably every like 2 months. It was crazy. And you know, I mean, I'm super serious. I was so good at school, so you know, I was like this intense infector of strep. But then I got mine out, and then it's fine. I only get it like once a year now, so she should do it.
Lua still has them. Her roommate had hers out when she was about 30, so that had severe side effects.
Yeah.
At this point, I'm not sure about it, but we'll see. So, no sick, it was just an abundance of caution. Sorry for any scares and inconveniences. But we're back to kind of a normal schedule for this week. This week, Currently, the chapter 16 assignments are due tonight. We will have time to look at those in a minute. This week, we're going to be working on chapter 17, which is about electrical resistance instead of capacitance. If you've taken physics or physical science classes before that dealt with electricity, resistance is probably the one of the two that will be more familiar to you. So it shouldn't be too scary. We'll also have a lab this week about resistance, where we'll be playing with resistors. I've double checked everything. The lab is currently set up, so that should be good to go. And so this week, normal operating procedures. Next week, check the academic calendar real quick. Because that email, I assume that every student got the email about some days off being added to the calendar. I'm glad for that, because past year's been kind of a fever dream, and I think everyone needs more vacation days.
I have a question. So like, we were originally supposed to have April 5th off. I think that's Good Friday.
I think we still do.
That's
You're Good Friday and the Monday after.
Because I still had like, at the beginning of the year, I got a syllabus with like a test on Good Friday. So like,
Oops.
does that,
That wasn't me.
no, I don't think so. But, does that mean that I do?
If
I should
some,
probably ask.
no class meetings Friday, April 2nd. That's, is that
That
next
one is
week?
good Friday.
Oh, okay, that's what I meant, because April 5th was the.
Is the Monday we
Yeah.
have.
Okay. So next week,
Wait, can you make it
Nope.
like up? Because I can't really see, like, go to April.
oh, yeah,
Yeah.
okay. Last full week of March, normal. Next week, which is the end of March, start of April. Where's my cursor? What am I doing? Okay, there we go. So next week, start in March, we end in April. This day, Friday, 2nd, no class. Official
That's next
campus
week?
wide. Yes, it is.
Really?
Yes. That doesn't affect labs for us. So currently still planning normal lab for next week. But this particular class won't have lecture on Friday.
So what is the homework due for 17?
The 17 homework, if we get through 17 this week, should be due March 30th. Sorry, yes, March 30th is the current one. The assignment is already up. Again, if things get pushed around, push it back. It's currently labeled 17.1 because I'm rearranging a few things, remaking a few assignments. I have the old one saved as 17. I wanted to keep the old one for records, so the new one is 17.1. That's just my organization system. It's still your chapter 17 homework. Just to make that clear. In the email that was sent out, I think it said, I think it's that Monday the 5th off.
And then you also do the 13th, which is
And that's a Tuesday. How do you do
But that's like the week after too. It's like we get that Friday, Monday off, and then the next week we get the Tuesday off.
It is the week after?
The 13th is.
Okay.
It's like after like a week, let's just, or a month, let's just.
Yeah.
We're
Oh
nearing
my
the end.
God, May 9th is like the last, or May 10th or something?
Next start or this side?
Yeah.
This side.
Mine's
Okay,
the 12th.
so
Oh my God, I think it's.
That's marching.
Summer school.
no class Friday, April 2nd. That's really just going to affect one lecture in here that week. Still planning a normal homework and a normal quiz, but we won't have lecture that Friday. Going through the weekend. The weekend will be extra long because we now have this day off. Also doesn't affect this class directly, but I may be a little wary and a little lenient on the homework dates just because days off, no one's going to be working. And the second wellness day is Tuesday, April 13th, which is Tuesday, but not the Monday?
Yeah.
So
So is
just
that,
just a random Tuesday off?
yeah, yeah.
Well, it's supposed to be like you have a month left, so like both of them.
Yeah. Every time I click on something, the calendar vanishes. Okay, this week, normal. Next week, mostly normal,
Except Friday.
except Friday.
And then
Week after,
Monday off.
Monday off, doesn't necessarily affect this class. I might push the homework around just because, again, everyone's gonna be relaxing over the weekend, that's the hope.
But we still have labs that 29th week and the 5th week.
Yes.
Yes.
So, up till now, even though a couple scattered days off, normal labs through to this week. The week after, they are canning Tuesday. So, no lecture this day, which means no lab this week.
Yeah, because that's, yeah.
And don't we have a
Which
test?
ties into what I want to do anyway.
Isn't our test in here the 23rd of April?
Is it?
It's in that week.
I read it.
It's 20-something, isn't it, of April?
I put April 6th. Oh my God.
Yeah, no, that's not happening anymore.
Okay.
That's in 2 weeks, guys.
Yeah, no, that's not happening. I have to get through, we still have magnetism to talk about.
I knew it wasn't April, but for some reason I was thinking it was like the mid-20s of April.
Inevitably, none of my test estimates ever
No, the
become
first one.
reality. Really? The first one was correct?
Yeah.
Oh, thank you for another class. Inevitably, most of my test predictions never pan out when I expect that they will. Okay, so impending calendar, I'll be reminding you guys of things as they come up. So until this week, things will be mostly typical. A couple scattered days off though. Do we enjoy them? We all need them. Other business. How do you guys feel about, and do you have any questions about the chapter 16 assignments currently due tonight?
Did you go with like 7 or 8?
7 or
They
8?
seem kind of similar. And like I understand the concept, it's just like, there you have like older, like I think series and like the capacitance.
Ah, yes. So 7 and 8 are what I call hybrid circuits, because they have things that are in series and also in parallel. And I like to think of these as puzzles. You need to sort of simplify them one piece at a time from the inside out. I consider this one to be the longer one, so we'll take a look here. This particular problem, number 8, has a total of 7 capacitors in it, many of which are in series or parallel to something else. And my recommendation is we want to figure out the total capacitance for this whole thing. And it's not explicitly shown, but you can assume this is connected to a battery, so it is part of the circuit. And because of its unorthodox nature, you need to take it one piece at a time. And in general, I recommend working from the innermost piece and then spreading outward. Because you can't really go from the outside in, because if you start at A and you come here and say, okay, so we're going to branch, we have parallel circuits, except that this parallel branch has 2 things on it, and this parallel branch has 2 things on it. So you can't start by doing all of this in parallel first. So what I say by outside in is look at individual rows and start compressing those together. Yes?
What messed me up until I figured this out was that the way that the current flows affects the way that your series/parallel circuits look like. For example, like in that top one, your series are like in a line, like a horizontal line. Like that's how you get to series, so that means that your 3 and your 6 are parallel. But over here, like your series are like in a vertical line. So like they can be on top of each other, but they're not parallel because they're still within that same line.
Right.
Yeah.
Series and parallel depend less on orientation and more about wiring. So we can track through each of these. Well, let's just go from, let's just say this is our battery and we're going to come out of it. We'll just look at what happens as the current goes through the circuit. Current's going to exit the battery, come through, hit junction A. Right after junction A, there's a split. And at that split, definition of a parallel circuit means some of the current is now going to go down each of these pathways, like a three-way fork in the road. Some of that current is going to go this way. It has to go through both C1 and C2 before remerging. The other wing has its own version of C1 and C2 that the current has to go through before remerging. And the other branch, the current has to go through C3 before remerging. So that's three different pathways. Any electrons that go down this rightmost branch are not going down the other two branches simultaneously. So if we had a tool to measure electrical current through this, say we had 3 amps coming in, each branch might get one of those 3 amps. And then they would come back together and remerge here. So because the current split, these 3 branches are parallel to one another, but 2 of those branches have things in them in series. So after this split occurs, I'm just going to tweak this a little bit. After the split happens, this split, the current has to go through C1 and C2 before it remerges. That means that even though this whole wing is parallel to these other wings, these 2 elements on the wing are in series with one another.
But C3 is just by itself, right?
C3 is by itself. The current that goes down this branch only travels through C3 before remerging. So at this moment, C3 is just by itself on its own parallel branch. Once the current remerges, it's going to travel down, it's going to hit this other junction, and then it's going to split down these 2 different parallel pathways, and then keep going. Remerge and then keep going.
C2, the 2 C2s are parallel because you have to split your current.
Yes, these 2 C2s are parallel to each other. But as a whole, like this whole piece right here,
Is in series with that, yeah.
yes. So we've got 2 chunks that are in series with each other, but we've got within those chunks a lot of various splits in series and parallels. Yes.
So C1 and C2 are not parallel to each other because you didn't have to split like any currents there.
Correct. After this split occurs, any current that goes left goes through C1 and then has to go through C2. So C1 and C2 on this row are in series. These 2, this C1 and C2 are also in series. This C3 is by itself in parallel with each of those wings. So when I say from the inside out, I recommend looking at individual rungs, like individual parallel rows, and starting to compress things one piece at a time. And they're all different. There's not going to be one guaranteed tactic for every single type of these questions because this one is a little bit different. Here we're going to, current comes in, it's going to split. This pathway is going to go through the 6. This other pathway is going to go through the other 2 before remerging and passing through the last one. So they're all different.
And that one, the top 2, like the C and the 3, are those parallel to each other since you go straight through?
So this C and this 3 are in series with one another. Because after the split, any current that goes through the C also has to go through the 3 before it remerges. So once the split occurs, anything that it has to travel through before it remerges or splits again is series. Series is more about direct cascading line of travel than it is about, being drawn in a straight line. So just looking briefly back at this one, what I would recommend doing is, before we can really do much else with this particular chunk, like we've got 3 parallel rows, but 2 of those rows have things in series with one another. So we need to start compressing and figuring out equivalent capacitances before we can move forward. So when finding equivalent capacitance, you're functionally just figuring out what, if you're like adding 2 capacitors together, you're just figuring out what their combined form could be if you were to plug in 1 capacitor instead of the 2. So if we perform the series operation to combine C1 and C2, that's going to give us some combined capacitance. We can redraw this as just 1 capacitor. And since the other row has a C1 and a C2 in series, we'll have the same number here. Once we've done that, whatever you found for these 2 is the same, is in parallel with the middle one now. And it's just parallel, there's no series weirdness, it's just 3 capacitors in parallel.
You just add them together.
Yep, whatever these 3, like, you perform the math on the series math on C1 and C2, that'll tell you what, I call these A and A. Whatever your A equals is now parallel to C3. You can do the parallel operation, which will, you just add them together, and that'll combine them further to just 1 capacitor. I call that one B. So now B by itself is in series with these other 2, with this chunk. This chunk has 2 things in parallel with one another. So these are just going to need to be added together. We call that C. And now we just got 2 things in series. From the series operation, you found the total capacitance for the whole circuit. It's simplification and combination, just 1 chunk, 1 row at a time.
The same thing with 7, it's just different.
Correct.
ways.
Same tactic with 7, doing the same thing, just, different configuration. Up here, I'd say the most limiting factor is that these 2 things are in series with one another. So I'd say perform the series operator on C and 3. Once you've combined those, that is in parallel with 6. So you can do that parallel operation. And then those 2 combined are in series with 20. And yes, these are tricky. And yes, doing them on WebAssign isn't the best because it just asks for 1 answer and all it says is right or wrong. And frankly, in math, there's way more ways to get things right, way more ways to get things wrong than there is to get things right.
Also, doesn't number 4 deal with capacitance too, but it's a lot more numbers?
Yes, 4 is also equivalent capacitance. Oh.
Because that was another one.
Oh, yeah.
Calculated something like that. I was like, that's a lot.
It's like calculate each thing.
I'm probably gonna change the weighting of each of the parts of this assignment.
So for like part A, we're doing what we just talked about, finding it equivalent capacitance.
Yeah, part A is the same type of thing we were just talking about.
And then the charges, that's where voltage comes in, right?
Correct.
Because isn't it like, is that Q? Or,
Yeah, so Q equals CV. I may end up cutting or modifying this question
because if this involves voltage splitting and voltage drops that I talk about with resistors, I haven't talked about it with capacitors. So I might be editing this question. That means it'll just be simpler for you guys to finish up tonight. So I apologize. The way that the old assignment was laid out is a little different to move towards teaching things. Good question.
Yeah. Can I ask about 5?
5, 2-point charges.
So, I know you need voltage, but I don't know what formula you use to get volts, but include 2 charges. Or, yeah, I think a radius. Like I know we said V equals negative E delta X, right?
Correct.
And then E, we talked about being K Q source over R squared, right?
Mhm.
But then you don't, like, to get the answer, you don't square the R. And also, what did you do with the delta E and V equals negative E delta X? I'm gonna just say delta X.
No, that's fair, that's correct.
Or was that delta X equal to the R, and so when you multiplied it, you got rid of one of the squared at the, oh my god, that's totally it, isn't it?
Well, you're halfway between the two charges, so. Okay, the E field between the two charges would actually be the sum of the other two E fields. 'Cause they're both going to be working together and overlapping. Midway between, so that's going to be R over 2 squared. You have two particles, each creating an E field. Those E fields are going to overlap and add up in the middle. So this is the total E field between the two charges. That total E field should then go on to be used here.
Oh, so you solve it first, your E field, and then you put it in?
Yes.
And then is your X the half of R as well? Or is
It
it-
should be, yes.
And then, like, B, I know we talked about the PE. Or V equals PE over Q. So would you multiply the voltage, well, what Q would you use?
Sorry, can I ask you to repeat that?
For B, for potential energy, I know that we talked about V equals delta PE over Q, right?
Yes.
But what Q do we use
Oh, right.
to multiply?
What is the potential energy of energy? I'm beginning to like this question less and less every minute. Adding up the potential energy of each charge within each other's field. Okay. My official ruling is that this is not a good question for the way that I have been teaching you guys information. I'm sure this exists, but if I can't figure it out intuitively and quickly, then it's not a fair question for you guys. Based on how I've been explaining this, I just don't like this one. And I'm sorry that it made it into this version that you guys have been working on. So, here's as though I'm going to be further editing this assignment tonight. In the interest of fairness, if I end up replacing this question, I'm going to extend the due date for everything. Just for fairness sake.
Wait, what if we're good?
This question,
Yeah.
if you have correct answers,
Yeah, I mean, I had to look it up. And then I found out, like, I understand that part now with the E fields, but I just could not get B. But, I mean, I did it.
well, B is the part that makes the least sense. So maybe I should just, I can edit it to where B is not worth any points. I can't explain to you what WebAssign's asking for here in retrospect. This question made it in because of parts A and C. But if I can't tell you exactly what the computer is specifically asking for because it was written by a bunch of tired physicists 10 years ago, then I'm not going to hold it against your account of the points. So, in what I'm going to edit tonight, I am going to make this part worth nothing, because if I can't explain it to you, it shouldn't be held, it shouldn't be worth it. I'm going to change the assignment weighting such that all of these rapid fire little bits are worth nothing or next to nothing. Because I have not talked to you about how voltage splits and drops across elements of the circuit yet. Okay. I apologize for the issues with this assignment. This is,
And on four, like, so, the very small ones, are those two parallel with each other? Are they?
These
in a
two?
series? Yes.
these two are parallel with each other, yes.
Okay. And then they're in a series with the other two.
Correct. So, For this one, take these two, perform parallel on them, and functionally that will just then give you three things in series with one another. Okay. I'm thinking I'll make a few weighting changes. I'll push this due date to Thursday. I would like to end today at least talking a little bit about resistors, because that's, if nothing else, that's what lab is about. Any objections to close on resistance preamble? Okay. So, within a circuit, the purpose of a capacitor is to hold charge, to hold energy and stuff. And this is the symbol we use for a capacitor within the circuit. This is just one of many electrical components that gets put into circuits. Another common component, arguably even more common, is a resistor. So the symbol for a resistor is kind of like an EKG or a Charlie Brown squiggly line. And resistors resist. That is their function. Whereas a capacitor is designed to store energy, hopefully to be used for later, resistors use energy. And
But what do they resist?
they resist electrical current traveling through them. There we go. So this is a slide from the chapter 17 notes. Resistance is measured in units of ohms. So actually I'm going to change the slide real quick. Resistors have a property known as resistance. So finally the names make sense. And electrical resistance is an object's tendency to prevent electricity from traveling through it. If an object has high electrical resistance, electricity will not very easily flow through it. You've probably encountered electrical resistance and lack thereof in your lives. What is something you can think of that should have high electrical resistance? And that it doesn't let electricity travel through it. Okay. So anything you've ever heard of that doesn't conduct electricity, rubber, wood is a pretty common idea for a resistor.
Isn't it just like non-metals, non-ionic?
Yes, most non-metals are worse conductors than most metals. So resistance is a measure of an object's ability to prevent electricity from traveling through itself. So if something doesn't conduct electricity, it has high resistance. On the opposite hand, if something does conduct electricity, it has high conductivity and low resistance. The thing is, though, every single thing has some level of resistance. All matter has, every object has some amount of resistance. It's just a question of how much. Because all matter, to some degree, resists electricity passing through it. The objects known as resistors that we plug into circuits are simply devices that are designed to have a very specific resistance so that we can manipulate the circuit accordingly. Everything has its own specific resistance. There are formulas to calculate it. Your body has a resistance, and it's a pretty high electrical resistance, thankfully. Your skin is designed to be somewhat resistant to electric shock. So humans, pretty resistive actually, considering that we're filled with water. We certainly conduct less than metal does. So, the property of resistance, every object has some resistance. The resistance that it has depends on what the object itself is, what it's made of, its size, etc., its temperature as well. One of the reasons that computers can overheat is because when the machine gets hotter, all of the components increase in their resistance, which messes with the electricity.
Wait, so increase in temperature, increase resistance?
Yes. Because resistance is ability to block electricity passing through you. When objects are hotter, it just gets harder for electricity to make it through that object.
I thought it would be the exact opposite.
So the reason why server rooms are kept super cold is because they just work better at colder temperatures. Things conduct better at low temperature because the atoms themselves are stationary, and that leaves more room and more freedom for the electrons to surge through them. If the atoms are jumpy, that slows down the train of electrons.
So higher temperature, more resistance.
Sorry?
If the temperature is higher, there's more resistance?
Correct.
That means that electricity will not push through.
Correct. High temperature, high resistance, less electricity making its way through the circuit. And what we're going to do, one of the things we're going to be looking at in lab shortly is how circuits work with resistors in them, either instead of or in addition to capacitors. So the two circuit configurations we've already been talking about, you can make them out of resistors as well as capacitors. So we still call them series and parallel. The weird thing is they're going to add up differently. So each of these components has its own resistance. The unit for resistance is ohms. We use the omega symbol for that. So each of these can be like 10 ohms, 1,000 ohms, 10,000 ohms. And all the math we just did for capacitors, those formulas are still true, but they're switched.
So series is parallel.
So in series, our total, they add up linearly. And in parallel, they add up inversely. This is because, since the purpose of a resistor is to resist current traveling through it, if you put resistors in series, stack them one after the other, you're building a continuous chain of resistance, a continuous chain of prevention. That makes it harder for the current to make it through the circuit.
Because even less went through, like, the first, so you have current and then the resistor, and then less of the current, right? Like less what charge, less what?
Yes, less current. It's harder for the same amount of current to make its way through. If you chain the resistors in series, it's just blockage after blockage after blockage, which is why in series, resistors add up linearly. In parallel, though, the current has the current, it's now a multiple choice test. The current can just choose to go down the easier pathway. So by giving it multiple branches to pick from, that inherently makes it easier for the current to flow.
Like the lower arrow will go through the lower resistance.
Most of it will go down the lowest resistance.
Is it like the last one where it's like one like loop only goes through one part of the parallel?
Right, so say we have 5 amps coming out of the battery. 3 of those amps might go through the first rung, the next rung might go 1 amp, the second rung, the third rung might go 1 amp.
Oh, this is at the same time? Was that in the last one too?
That was happening, we just weren't measuring the current yet.
Oh, okay. Okay.
And we'll talk more about this in lab. Lab might be a little more lecture heavy than normal, but I'm going to divide it up into pieces and we're going to experiment and mess around with the circuits in between all of the me just talking at you. So we'll continue this in lecture and in lab this week. Big things to note before we get to those activities. Resistors have resistance. Resistance has a tendency to resist electricity traveling through you, measured in ohms. The homework due date is being pushed to Thursday. And let me know if you have any questions. And we'll see you all soon again. Have a great day. Stay healthy.